Since the dawn of our existence, we have gazed upon the stars, captivated by the shimmering points of light that punctuate the night sky. They have inspired our myths, guided our explorations, and fueled our imaginations. But as our knowledge has grown, so too has our ambition. The stars, once distant and untouchable, now beckon us to reach beyond our world, to explore the great unknown. But space is a harsh and unforgiving frontier. The challenges it presents are monumental, and the obstacles to long-distance space travel are many. To journey far beyond our planet, we must confront the very limits of our technology, our biology, and our understanding of the universe. The first and perhaps most daunting obstacle is the sheer vastness of space. Distances between celestial bodies are mind-bogglingly immense. To reach even our closest planetary neighbor, Mars, we must travel over 225 million kilometers, a journey that would take many months with our current technology. But Mars is merely a stepping stone. To reach the nearest star, Proxima Centauri, we would need to travel over 4 light years, a distance of more than 40 trillion kilometers. At the speed of our fastest spacecraft, this journey would take tens of thousands of years. We are confronted with a paradox. The more we learn about the universe, the more we realize how small and slow we truly are. Our spacecraft, magnificent as they are, move at a fraction of the speed of light. To explore the cosmos, we must overcome the challenge of distance, and that means rethinking the very nature of travel. At the heart of this challenge lies propulsion, the means by which we propel ourselves through space. Our current methods, reliant on chemical rockets, are powerful but inefficient for the vast distances of space travel. To reach the stars, we must develop new forms of propulsion, capable of propelling us faster and further than ever before. Among the most promising candidates are ion drives, which use electrically charged particles to generate thrust. These engines are highly efficient, capable of sustained acceleration over long periods, but they are still slow by interstellar standards. Another possibility is nuclear propulsion, harnessing the immense energy of nuclear reactions to propel us through the void. Yet, these technologies are still in their infancy, and their development poses significant technical and ethical challenges. But even these advances may not be enough. To truly traverse the stars, we may need to explore the realm of the theoretical, the idea of warp drives, bending space-time itself to allow faster than light travel. It is a concept born of science fiction, but one that has captured the imagination of physicists and dreamers alike. Yet, even if we solve the problem of propulsion, we must still contend with the fragility of our own bodies. We are creatures of Earth, evolved to thrive in its atmosphere, under the pull of its gravity, and shielded from the harshness of space by its magnetic field. In space, these natural protections are stripped away. Without gravity, our muscles weaken, our bones lose density, and our fluids shift, leading to a host of health issues. Prolonged exposure to microgravity can result in vision problems, cardiovascular deconditioning, and even changes to the structure of the brain. to survive the long journeys required for deep space exploration, we must find ways to mitigate these effects. Exercise regimes, artificial gravity, and even pharmacological interventions are being explored, but solutions remain elusive. More concerning still is the threat of cosmic radiation. Beyond the protective shield of Earth's atmosphere and magnetic field, astronauts are exposed to a constant barrage of high-energy particles. Over time, this radiation can damage cells, increase the risk of cancer, and cause other serious health issues. Protecting our explorers from this invisible danger is one of the greatest challenges we face. And then, there is the human mind, resilient yet vulnerable. The psychological toll of long-duration spaceflight is a challenge not to be underestimated. Isolation, confinement, and the knowledge of being millions of kilometers from home can weigh heavily on even the strongest individuals. The absence of Earth, its colors, its sounds, its life can lead to a condition known as Earth out of view phenomenon, where the detachment from our home planet causes deep psychological distress. Loneliness, depression, and anxiety can creep in, threatening the mental well-being of the crew. To counter these effects, researchers are exploring the use of virtual reality to simulate the experience of being on Earth, providing astronauts with a semblance of nature and a connection to home. But these are only partial solutions. The true challenge lies in preparing the human mind for the rigors of deep space travel. As we contemplate the journey ahead, we are reminded of the immense challenges that lie before us. The vastness of space, the limits of our technology, the fragility of our bodies, and the resilience of our minds all must be overcome if we are to venture beyond our solar system, to the stars that have called to us for millennia. Yet these are just the beginning of the obstacles we face as we set our sights on the distant stars. As we venture further from Earth, the complexity of maintaining life support systems grows exponentially. On a journey that could span years, or even decades, every aspect of our existence must be carefully managed. We are, after all, taking a small piece of Earth with us into the void. One of the most critical aspects is the supply of air, water, and food. These are the essentials for life, but in the cold vacuum of space, they are precious commodities. Our current spacecraft rely on intricate systems to recycle water and air, extracting oxygen from carbon dioxide and purifying wastewater. But these systems are not foolproof. They are complex, prone to failure, and require constant maintenance. The challenge of food is no less daunting. On Earth, we are accustomed to fresh produce rich in nutrients. In space, fresh food is a luxury. Astronauts rely on pre-packaged meals, carefully balanced to meet their nutritional needs. But these meals have a limited shelf life, and over time, they can become monotonous, leading to menu fatigue, which can affect morale and health. To sustain a crew on a long-duration mission, we must develop advanced methods of growing food in space. Hydroponics, where plants are grown in nutrient-rich solutions, and aeroponics, which use mist, are promising techniques. But growing food in microgravity presents unique challenges. Plants evolved on Earth under the influence of gravity, and their behavior in space is still not fully understood. Beyond the essentials, there are the logistics of waste management. In the confined environment of a spacecraft, waste can accumulate quickly, and it must be carefully managed to avoid contamination and maintain hygiene. Recycling systems are essential, but they too are complex and prone to malfunction. Then there is the challenge of energy. A spacecraft traveling through the void cannot rely on the constant, abundant sunlight that powers our lives on Earth. Solar panels become less effective as we move further from the sun, and the use of nuclear power presents its own risks and challenges. Energy must be carefully rationed, used efficiently, and stored safely. But even if we solve these technical challenges, we must also consider the social and cultural aspects of long-duration space travel. A journey to another star could take generations. The people who set out on this voyage may never see their destination, leaving the task to their descendants. This raises profound questions about motivation, purpose, and the preservation of knowledge and culture over such vast timescales. How do we maintain a cohesive, functioning society in the isolated, confined environment of a spacecraft? How do we ensure that the knowledge, skills, and traditions of Earth are preserved and passed on to future generations? These are questions that go beyond engineering and into the realms of psychology, sociology, and philosophy. And then there is the unknown. Space is not empty. It is filled with dangers we are only beginning to understand. Micrometeoroids, traveling at speeds of tens of thousands of kilometers per hour, can puncture a spacecraft's hull. Radiation from distant stars and galaxies can interfere with electronics, damage DNA, and disrupt communications. Even more mysterious are the phenomena we have yet to encounter. Strange forms of matter, gravitational anomalies, and other cosmic hazards could lie in wait, posing threats that are beyond our current understanding. The challenges we face are immense, but so too are the rewards. The quest to explore space is not just about survival, it is about discovery, about understanding the universe and our place within it. It is about reaching out beyond the cradle of Earth to touch the stars. For now, we must acknowledge that the path ahead is fraught with difficulty. But as we have done throughout our history, we will face these challenges head-on, driven by our insatiable curiosity and our unyielding desire to explore. The stars have called to us for millennia, and now more than ever, we are preparing to answer that call. As we conclude this chapter, we stand on the brink of an extraordinary journey. The challenges of space travel may be daunting, but they inspire us to push the boundaries of what is possible, driving us to innovate, adapt, and persevere. We will continue our exploration, delving into the technologies and ideas that could one day take us beyond our solar system. For now, let us remember that our quest to reach the stars is not just a journey through space, but a testament to the enduring spirit of human curiosity and determination. Until next time, keep looking up and keep dreaming.